All right, today we are going to revisit our good friend, the letter E. So, e to the x, Euler's number, is, remember this guy? And then we've got our natural log of x. So we're going to look at derivatives of these two functions today. So the derivative of e to the x and the derivative of the natural log x. Now, the derivative of e to the x is so fabulous because guess what it is? It's e to the x. So it is its own derivative, which makes sense because remember when we originally studied this and we said that the beauty, wow, I totally missed. The beauty of this is that it is its own slope. Well, remember that a derivative is nothing more than a formula for slope. So it makes sense that the derivative of e to the x is e to the x. The derivative of the natural log of e. Now remember, the natural log is just a log with a base of e. The derivative of the natural log is 1 over x. Again, super simple. Now, of course, things can be a little more complex because what happens if our x is its own function? So let's rewrite that as e to the f of x. So like we learned in logs and exponentials, we're just going to enact the chain rule here and multiply by the derivative of f of x. So the derivative of e to the x is e to the x. So the derivative of e to the f of x is e to the f of x times, chain rule, the derivative of f of x. Likewise, the derivative of a natural log that has an f of x. So that same situation, the derivative of that is going to be 1 over f of x times, chain rule, the derivative of f of x. And, just like a little secret side note, just so we're clear, if you take 1 over f of x and multiply it by the derivative of f of x, you'll see quickly that that's the same as f prime of x divided by f of x. Just as a side note, but we'll talk about that more later. Okay, take screenshot. This is a good one. Okay, let's do some examples. So, what if we have, let's take the derivative of e to the 3x squared. Okay, so this is e to the x, and remember our x is 3x squared, so it's really e to the f of x. So the derivative of e to the x is e to the x. Now we're going to multiply that by the derivative of 3x squared, which is 6x. So we can leave it like this, or you can rewrite it with the 6x in front. How about the derivative of e to the 4x plus 2? All right, so the derivative of e to the x is e to the x. Multiply by the derivative of 4x plus 2, which is 4. So clean that one up, 4e to the 4x plus 2. Okay, not too bad. What if we have, I don't know, let's get crazy. The derivative of e to the 4 divided by x. Ooh, slight wrench in the system. Okay, we always just rewrite it. Its derivative is itself. But now we need to take the derivative and multiply this by the derivative of 4 divided by x. Well, 4 divided by x is the same as 4x to the negative 1, right? And the derivative of that is negative 4x to the negative 2. So I'm going to put that in. So times negative 4x to the negative 2. Everybody okay with that so far? Okay, can we make that look a little better? Oh, I don't know. It's kind of ugly. Negative 4e to the 4 over x squared. Well, questionable. No good way to make that look nice. Okay, how about natural logs? Let's say we've got the derivative of the natural log of 3x squared. Okay, so remember, the derivative of ln x is 1 over x. So in this case, my x is 3x squared. So the derivative is going to be 1 over 3x squared times f prime of x, which is 6x. Multiply that through, and we have 6x over 3x squared. Simplify, and we're going to end up with a 2 over x. Okay, this simplify step is going to show up just about every time. Don't mess that up, okay? But also, don't jump the gun on that, okay? It's easy to get a little overconfident. Okay, what if we have this? What if we have the natural log, the derivative of the natural log of 4x plus 2. Okay, so this time our x is 4x plus 2. So the derivative is going to be 1, oops, I don't know why that's red. 1 over 4x plus 2 times the derivative of 4x plus 2. The derivative of 4x is 4. So 4 over 4x plus 2. Simplify. Take out a 2 and you have 2x plus 1. Cancel. And you have 2 over 2x plus 1. Don't let that middle school math get you. Okay. Ready? Let's get wild here. What is the derivative of the natural log of 2x squared times e to the x? I want you to pause. See if you can solve this and be careful. Okay. Couple things happening here. Our x is this monstrosity. It's really not monstrosity, but that's product law, right? So this is going to be our f of x, and this is our g of x. So we need to be real careful with this dude. All right, so here we go. The natural log has a derivative of 1 over x. So 1 over 2x squared e to the x times g f g, because it's product. So g e to the x, f prime 4x plus f 2x squared, g prime e to the x. Okay, line it all up. Let's rewrite that, sorry. 4x e to the x plus 2x squared e to the x over 2x squared e to the x. Okay, what can we cancel out here? What can we factor out? Let's look carefully at just in the top. I've got an x and an x, right? Can factor out an x. I have an e to the x and an e to the x that I can factor out. And then there's also this 4 and 2. So I've got a lot of stuff I'm going to factor out. I'm going to factor out a 2, an x, and an e to the x. And what does that leave me? That leaves me a 2 plus x. And in the denominator, I have 2x squared e to the x. So I'm going to cancel my 2. I'm going to cancel my e to the x. This x cancels, and it's just going to leave me 1. So all that we have left is 2 plus x over x. Don't let that get you. Okay, I think that's all there is to it. All right, good luck.